Hi! In this chapter, we will be talking about advanced SQL topics. After completing this chapter, you will be able to manipulate the structure of existing tables to add, modify, and remove columns and constraints, use SQL to create database views, use procedural language SQL or PL/SQL to create figures, stored procedures and functions, created embedded SQL, identify anonymous PL/SQL blocks, and retrieve data and process PL/SQL statements by using cursors.
As we have learned earlier, the output of a relational operator such as select is another relation or table. Suppose in our JustLibBooks database, at the end of each day, we would like to know what are the books being ordered. Instead of typing the same query at the end of each day, wouldn't it be better to permanently save that query in the database? That is precisely the function of a relational view. A view is a virtual table based on a select query. That query can contain columns, computed columns, aliases, and aggregate functions from one or more tables, and are basically used for a better business function. The tables on which the view is based are called base tables. The following is our syntax in creating views. We first start with the create view keyword, then the name of our view, the keyword as, and then our select query. Take for example our JustLibBooks database. If at the end of the day we would like to know which orders have not been shipped yet, we will be inclined to run the following script. Select order number, order date, item number, ISBN quantity, from orders, natural join order items, where the ship date is null. Instead of running the same script over and over again, we can create a view which is a virtual table, name orders underscore EOD as we can see in our slides in here, and select from that virtual table that we have just created, or view. And as we can see from here, if we have select queries that are extremely long and we would like to have a shortcut in running them every single time, we can create views so that we will save time and processes. These are some characteristics of views. First, you can use the name of a view anywhere a table name is expected in a SQL statement. Since a view is literally a virtual table, you can use it as if it is a table itself. Second, views are dynamically updated. In particular, the view is recreated on demand each time it is invoked. Unlike tables, views are not storing the data that we are storing in a table. Instead, they're only fetching the data from our table whenever we need them. Thus, a call from a view today may have a different result from a call with a view tomorrow. Third, views provide a level of security in the database because they can restrict users to seeing only specified columns and rows in a table. As we have seen in our previous example, we can only define the columns that we would like to show in our view. Thus, other columns that are not called from the table are not being shown. And lastly, views may also be used as the basis for reports. One of the most common operations in production database environments is to use batch update routines to update a master table attribute or field with transaction data. As the name implies, a batch update routine pulls multiple transactions into a single batch to update a master table field in a single operation. For example, a batch update routine is commonly used to update a product's quantity on hand based on summary sales transactions. Such routines are typically run as overnight batch jobs to update the quantity on hand of products in inventory. As its name suggests, an updatable view can be used to update attributes in any base tables used in the view. You must realize though that not all views are updatable. Actually, several restrictions govern updatable views, and some of them are vendor specific. Some of the restrictions that we have are the following. First, group by expressions or aggregate functions cannot be used. Second, Set operators cannot also be used. And last, most restrictions are based on the use of joins or group operators in views. A sequence is a set of integers that are generated and supported by some database systems to produce unique values on demand. If you use MS Access, you might be familiar with the auto-numbered data type, which you can use to define a column in your table that will be automatically populated with unique numeric values. In fact, if you create a table in MS Access and forget to define a primary key, MS Access will offer to create a primary key column. If you accept, you will notice that MS Access creates a column named ID with an auto-number data type. After you define a column as an auto-number type, every time you insert a row in the table, MS Access will automatically add the value to that column, starting with 1 and increasing with the value by 1 in every new row you add. In MS SQL Server, a table can have at most one column defined as an identity column. This column behaves similarly to an MS Access column with the auto-number data type. MySQL uses the auto-increment property during table creation to indicate that values for an attribute should be generated in the same fashion. Oracle, however, does not support the auto-number data type or auto-increment column properties. Additionally, Oracle uses a sequence to assign values to a column on a table. However, beginning in Oracle 12c, Oracle has added support for identity columns, and beginning in MS SQL Server 2012, SQL Server supports sequences. There are many similarities in the use of sequences among these DBMS. One of which is that sequences are independent objects in a database, meaning they are not data objects or data types. Next, sequences have a name and can be used anywhere a value is expected. Also, sequences are not tied to a table or column. Sequences also generate a numeric value that can be assigned to any column in any table. And last, table attribute with an assigned value can be edited and modified. The following is the basic syntax in creating a sequence. First, we have the keyword create sequence. Then, we specify the name of the sequence. And then we have start with, which specifies the initial sequence value with the value n, which is an integer value that can be positive or negative. Then the keyword increment by, which determines the value by which the sequence is incremented. And then the value n, which can also be positive or negative. And then cache or no cache indicates whether the DBMS will pre-allocate sequence numbers in memory. Oracle uses no cache as one word and pre-allocates 20 values by default. Let's take a look at the following examples. First, we create a sequence called emp_seq, starting with the value 1 with no cache. And then, now that we have created our sequence, Oracle 12 allows us to use as default value that sequence dot next val in our primary key. Alternatively, in Oracle 12c+, we can use the identity as we can see in here. Emp number is generated always as identity, starting with 1, increment by 1. And once we have done this, if we're going to insert values into our employees table, we no longer need to specify the value for emp number, and we only need to specify the first name and the last name. And if we try to take a look at our select from our table, we will see that we have generated automatically the values for the emp number.